Welcome to today's video. In this video, I'm going to talk about properties of similar triangles. So I'm going to talk about what two triangles have for them to be similar triangles. So stay tuned, watch this video up to the end as I'm going to share with you the properties of triangles that are similar. Okay, so triangles are similar if one of the following conditions apply. So triangles can only be similar if they are one, their corresponding sides are in proportion, meaning corresponding sides are proportional. Okay, so to explain on this one, let me draw these two triangles. Okay, so these are two triangles and these are the names of corners of triangles. Okay, so triangles can be similar if their corresponding sides are proportional. Now we are able to tell that AB, let's write the corresponding sides. We can say we're able to say AB is proportional to AB is corresponding with ST in the bigger triangle. AB in the smaller triangle is corresponding to ST. Okay, these sides they are the same. These are the same sides. AB and ST, they are the same sides. They are corresponding sides. Okay, then which is equal to, then we can say BC is corresponding to TU. Okay, then AC, the side AC is corresponding to the side SU. Okay, so as you can see, the sides on top are coming from the smaller triangle, and then the sides down they are coming from the bigger triangle. Okay, so these are the corresponding sides. So AB is corresponding to ST, BC is corresponding to TU, and AC is corresponding to SU. Okay, so now let's replace these sides by their measurements. Okay, so we have AB is equal to 5 centimeter over ST is equal to 10 centimeter, then which is equal to, then BC is equal to 8 centimeter and TU is equal to 16 centimeter, then AC is equal to 10 centimeter and SU is equal to 20 centimeter. Okay, all right. So these are the corresponding sides and their measurements. Now, when we write these, I've written them in a fraction way or ratio way. Now, when these are reduced to the lowest term, their lowest term, they should have the same fraction or ratio. They should have the same ratio after reducing them to the lowest term. Or if you want to okay, so what you're going to do is we're going to try to reduce them and they should give us the same ratio. So here we have 5 over 10, 5 centimeter over 10, so we can find the number that can go into these two numbers. So 5 can go in both, so we're going to divide the number on top and the number down by 5. So we say 5 into 5 will give us 1, 5 into 10 will give us 2 centimeter. Okay, 5 into 5 centimeter give us 1 centimeter, and 5 into 10 centimeter give us 2 centimeter. Then, which is, now we come to this one, 8 centimeter over 16 centimeter. So which number can go into both? 8 centimeter can go into both. So 8 centimeter divided by 8 will give us 1 centimeter. 16 centimeter divided by 2 centimeter will give us 2 centimeter. Then we can say equal to, then we go to that one. Then what number can go into 10 centimeter and 20 centimeter? That is 10 centimeter itself. So we're going to have 10 into 10 centimeter will go 1 centimeter. Then 10 into 20 centimeter will go 2 centimeter. Okay. Now, as you can see now, here we have gotten a ratio which is the same. Okay. Therefore, we can say these two triangles are similar because their sides are proportional. When the sides are proportional, when you try to reduce them to their lowest ratio, you find that they will give you the same ratio. Then if they do that, that means these triangles are similar. Okay, so that's the one point you should consider, is that their corresponding sides are in proportional. And how do you test that the corresponding sides are proportional? When you reduce them to the lowest ratio or fraction, they will give you the same fraction or ratio. Okay, so basically this is how you can identify that the triangles given are similar. Let's go to the next point. So the second condition that can help us to determine whether the the triangles are similar is their corresponding angles are equal. Okay, so if their corresponding angles are equal, then the two triangles are similar. In other words, they are equingular. Okay, so if you find that the two triangles have got congruent angles, then these triangles are similar. Even if the lengths are different, as long as they have got congruent angles, then they are similar. Let's look at these two triangles. Okay. Okay, so these are the two triangles which I've drawn, and you can see those are their corners B, A, C, and you have got X, Y, Z there. Okay, so when you look at these angles, they are corresponding angles. When you look at angle BAC, which is 105 degrees, and angle YXZ, which is also 105 degrees. Okay, so these angles, the two angles, they are equal. Then we also look at these two angles. The first one is ABC, which is 40 degrees, as well as XYZ, which is 40 degrees. We also look at these two angles, which is ACB and angle XZY, which are 35 degrees. These angles are equal. So let me try to write their angles, their reading. Okay, so we have got here 105 degrees for angle BAC, and we also have got 105 for angle YXZ. Okay, so these angles, they are equal. The reading is just the same. We can also look at angle ABC, which is 40 degrees, as well as angle XYZ, which is 40 degrees. Angle ACB, which is 35 degrees, which is equal to XZY, which is 35 degrees. Now, when you look at these angles, they are equal. The reading on these angles is just the same. So these angles are congruent. So we can say these triangles are similar triangles. Okay? let's go to the third point. Okay, the third condition is two pairs of corresponding sides are in proportion and one pair of corresponding angles are equal. Okay, so here we are saying a pair of corresponding angles are equal. So if two triangles which are given, the two sides given are proportion and then are proportion in size, and then the angle which is given in both is equal to each other, then those two triangles are similar. Okay, when we look at these triangles given down here, we have got triangle ABC and GHI. These are the two triangles given. Now when you look at the angle given, it's 55 degrees, and in both they are 55 degrees, they are equal. Then when you look at the sides given, when you look at 12 and 36, these numbers, they are proportional to each other. 12 is proportional to 36. When you look at 4 and 12 down, it's also proportional to 4 is proportional to 12 centimeter. So what we are trying to say is if the two angles given are equal and then the sides given are proportion, then the sides of the sides given are in proportion, then those two triangles are similar triangles. So we can say angle ABC is equal to angle GHI, which is angle ABC is 55 degrees and angle GHI is 55 degrees. So you can see these two angles, they are equal. Okay, so that point is fulfilled in these two angles. Now when we come to sides, let's look at side AC and GI. Okay, so when we look at AC is proportional to GI, and the length of AC is 12 centimeter and the length of GI is 36 centimeter. So when we try to reduce these to a lowest ratio, if we take these to the lowest ratio, you find that we are going to get 1/3. Okay, it's more or less like we have divided both numbers by 12, which will give us 1. 12 divided by 12 will give us 1. 36 divided by 12 will give us 3. So that's why I've come up with 1/3. So when you look at that ratio, that means we have gotten 1/3. That's a ratio. Okay. Now we can't say definitely this triangle is, these two triangles are similar, because we also need to check the other side, which is the side BC, which is proportional to HI. Okay, which is equal to BC is equal to 4 centimeter and 12 is equal to HI is equal to 12 centimeter. So when we divide these two numbers by a common factor, which is 4 can go into 4 and 4 can go into 12. So 4 into 4 give us 1, then 4 into 12 will give us 3. Now here we can come up with a ratio which is 1/2. Or 1/3, sorry, 1/3. Now, when you look at the first measurements we took, which is AC and GI, they also gave us the ratio which is 1/3, and BC also gave us the ratio which is BC and HI gave us the ratio which is 1/3. So the ratio is the same. So when proportional sides of two triangles give you the same ratio, that means the triangles are similar. When the proportional sides of two triangles give you the ratio which is the same, then those triangles are similar. So like we did in the first point, the point number 1, we use the sides to determine whether the triangles are similar. So as you can see this now, we can say that these triangles are similar. Okay, thank you so much for watching. It has been easy learning Z Mathematics.